So this is what we'll be going for. A simple ball that bounces around the window. A paddle that is controlled by the user's input. Bricks placed at random position that disappear on collision with the ball. We try to achieve all of this in 10 simple steps. All right, let's get into it. Before you start this project, you need to ensure that you have Python installed. You can come to this website and install the latest version of Python. And you can also check out the Pygame community website using this URL and install it also to get the Pygame library. This is an example of how you install the Pygame community edition using pip. And if you have that, we can start with step 1. Step 1, project setup. So in this step, we're going to create the Pygame window. We're also going to add a title. We'll set up the screen's width and height and other settings. And basically, when we are done, we should have a window that has a width and a height. We're going to define some grid pixels. So these squares, 40 by 40 pixels, will form the measurement for our game elements. To start off this project, we're going to have 3 files. We're going to have entities.py to hold all our classes, main.py, our main entry point into the game, and then settings.py to hold the settings. So for the settings, we install Pygame and some other Python modules. And also we have some constants that we'll be using in the game later. Right, so you can see here we have the grid pixel size set to 40 pixels. For now, the entity files doesn't have anything, just the inputs of the settings and then the random module. And then for the main.py file, we're going to import settings. To start off, we're going to create a class called GameApp. This class will have an init method. And then we need to initialize Pygame. Then we'll create our screen. And we can pass a tuple with our screen width and height. So in our settings file, we have screen width and height. So I'll just copy that, go back to the main file, paste this. So this will create the dimensions for our Pygame. You can also set the title of the window. using pygame.display set caption. And we also have another constant here called game title. So you can copy this. We would like to also create a clock, which we will use later on in the game. Oh, it should be capital. We need a flag to know when the game is running. We'll also keep track of the score for the player. We'll quickly create a method to close the game window anytime we're ending the game. So pygame.quit to quit the pygame, and sys.exit to close the window. We'll have another method called run. And in this method, we'll have while loop, here we'll quickly calculate our delta time, which will be used later for all the different entities that we'll be updating. We have FPS, our frames per second rate, and we'll convert this to milliseconds. We listen for an event. And the event we're interested in is when the close button of the window is clicked. When the close button is clicked, we want to end the game, and we'll call this end game function. Still in our while loop, we'll have a section where we'll keep updating our different elements of the game, and then another section where we'll draw all our elements in the game. We also like to set the color of the screen, and for that I would like to use this constant. You can check. This is the color we'll be using to fill our window. We'll call the pygame.display.update to keep updating our window. And with this, our class is done for now. So we'll make sure that when the user is running this file, we'll create an instance of the game app. And then we'll call the game.run function. So let's run this game and see how the window looks like. We have a small error. This is a constant and not a function. So let's run it again. And as you can see, this is our game window with the fill color, our caption, breakout, and then we can close it to exit the window. For step 2, we're going to draw our paddle. Our paddle is made from 3 of our grid pixels. Each grid pixel is 40 by 40, but we're only going to multiply the width. To draw our paddle, we'll go to our entities class and create a new class called paddle. And this paddle class will inherit the sprite class from pygame. Pygame.sprite.sprite. We need to call our init function so that we can initialize an object that is created from this class later. And we also need to pass groups, which will be our sprite groups to make some work easier later. Don't forget to pass the group to the init of the parent of our paddle class, which is the sprite. We'll set some properties of the paddle. So the width of our paddle will be our grid pixel size multiplied by 3. The height of our paddle would be the same as our grid pixel size. The color of our paddle, we'll use the orange constant that we've declared in our settings file, and the speed at which our paddle will move later will be the same as the paddle speed, which is inside our settings file. For the paddle sprite, anytime we create it, we'll create a pygame surface. And inside, and for this pygame surface, we have to pass a list with the width and height of our paddle. We need to also get a rectangle from our surface, our image surface. Using the get frect, which is only available on the Pygame Community Edition. And for this rectangle, we need to pass the center position for the image. So for this, we'll use the screen width divided by 2 for x, so that we get half of the screen width. And for the y-axis, we can use screen height, but we'll take away some pixels so that it's visible on our window. So if we take away, let's say 80 pixels from the screen height to form our y-axis. And before we leave this file, just want to quickly create an update method, which we'll use later when we are updating our paddle object later. So we'll just put past them. In the main file, we're going to create the paddle object. But before that, let's have a section for sprite and then create some sprite groups. So we'll use the all sprites group for all the sprites we draw for the game. And the sprite group can be found in pygame.sprite.group. This will make our job easier, especially when it comes to drawing or updating the sprites that belong to each group. We'll also have a paddle sprite. So the paddle sprite group, we'll use this later when we are checking for collision between the ball and the sprite. Then finally, we'll create our paddle object. And pass a tuple that contains both our groups. So self.allSprites and self.paddleSprite. Okay, so inside our run method in our while loop, after filling our screen, we can also draw our sprites. So we'll use self.allSprites.draw to draw all the sprites that belong in the all sprites group. I would like to draw them on the screen of our window. And before I forget, just quickly, I'll use the allSprites.update method so that we keep updating all our sprites before we draw them, even though for now we only have one sprite and inside it we're not doing any major thing. With this, I think we are set to test out the paddle entity. As you can see, this is our paddle, this black rectangle. So let's close that, go back to our entity. We can actually give it a fill color. Let's say we fill it with the self color, which is orange. Run it again, and we can see that our rectangle now is orange. Let me remove this for now. We're going to draw a rectangle. So we'll draw a rectangle on our image surface for the paddle. We'll give it a color. So the color of the paddle, which is orange. For our actual rectangle, we use the frect method in pygame. Here we need to pass the starting position relative to the image surface for our paddle. Next, we'll pass a list that contains the height and width of our paddle. So the width and the height of our paddle. And after the frect function, we'll specify 0 for the width, and then let's say 20 for our border to have curved borders. So this 20 is our border radius. Let's run the game again. As you can see, the orange rectangle is inside the square rectangle that is black. So this black rectangle is our image for our paddle, and this orange rectangle is actually what we want for the paddle. All right, so to get rid of these black edges, to get rid of those black edges, we use the pygame and then source alpha. And that will allow it to be transparent. So when we run it, we should only see the orange curved rectangle. For step 3, we're going to focus on moving the paddle. We want to move the paddle only along the x-axis and ensure that the paddle doesn't go beyond the boundaries of the window. So to move the boundary, I'll go to my paddle class, and inside my init function, create some new properties. This property will be used later for detecting the boundary between the ball and the paddle. For the paddle movement, we need to create a direction property. We'll also create a move method. Which we use delta time for the movement of the paddle. And then to move the paddle, we want to access the rectangle of the paddle and the X at the center of the paddle, and update that to the direction of the paddle multiplied by the paddle speed. And delta time and then just to make sure that we don't go across the border, if the rectangle for the paddle, the left position, is less than 0, then make sure to set it to 0. And if the rectangle's right position is greater than the screen's width, then set the right position of the rectangle to the screen's width. This will ensure that the paddle does not go out of the boundaries of our window. For now, our direction is 0, so nothing will happen. We need to create another function to get the direction that the paddle needs to move in. And this direction is determined by the input keys that the user will be pressing. So we need to get the user's input using pygame.keys.getPressed. And we want to check if the key is pygame.keys.getPressed. dot k underscore left. That means the user pressed the left arrow key. Then we need to go in the negative direction for x. The direction for the paddle should be -1. Else, if the key that's pressed is the pygame.kRight, that means the user pressed the right arrow key, then you move the paddle in the positive direction of x. Else, if the user is not pressing any key, then you can maintain 0 for the direction. We'll now need to replace this pass. So in our update function, first get a copy of the old rectangle for our collision with the ball later. Then get the direction of the paddle. And then based on that direction, move the paddle. So this should ensure that we're able to move the paddle left and right. Let me clear my terminal and run the main file again. And then we test this out. As you can see, the paddle is being moved when I press the left and right arrow keys. Step 4 is to draw the ball for our game. Our fall will be 40 pixels wide and 40 pixels height. So basically a grid pixel. And we want it to be round. So we're going to draw a circle. And the circle, we have a radius that is half of the grid pixels, which is 20. For the ball, we're going to create a new class. So class, the name of this class is now ball. It will also inherit the pygame sprite. Then we'll define the initialization function for the ball, which will take sprite group. We'll also pass the paddle sprite, which we'll use later to detect collision between the ball and the sprite in the game. Don't forget to pass to the parent init function the sprite group. We'll now set some of our properties for the ball class. So the paddle will equal to paddle sprite. The ball has a radius, which is half of the grid pixel size. The ball has a center position, which takes a list of radius and the radius again. For the ball color, we'll use dark orange, which we declared in our settings file. For the ball speed, we'll use the ball speed constant. And then we need a flag to check if the ball goes out of bound. We'll set it to false initially, and later during the game we'll check it. So our ball, we have an image surface. So pygame-surface. And for the X and Y starting position of the ball, we'll use the grid pixel size, which is 40. So that our surface will be 40 by 40. We'll draw a rectangle for our ball. Using the getFrect function. And for the center position of the ball, it's okay for the ball to start at the center. So the screen width divided by 2 for the X position. And for the Y position, we'll do screen height divided by 2. For collision later with the paddle, would set old rectangle for the ball to store the previous position of the ball. So let's save this and return to our main file. In our main file, we'll create a new sprite group called ball underscore sprite. For our ball object, we'll use the ball class and pass in self dot all sprites and self dot ball sprite as the group. So all sprites and ball sprite will form the sprite groups that the ball will belong to. Then we'll also pass the paddle sprites, which we'll use later to detect collision between the ball and the paddle. So with this, if you save, let's clear the screen and run the main file again. When you run the main file again, I have a spelling mistake in the attributes. So ensure that you've spelled properly self.radius. And this black square is our ball. So back to the entities class. We'll draw a cycle. The cycle will get drawn on our image with the color of the ball, which is orange. And the center position will be the center position of the ball. And then we need to also specify the radius of our ball. Let's run the main file again. And this time you see the orange ball in our black image surface. To remove the black background for our source image, pass the pygame.source alpha as a second parameter. Save that. Run the game again. And this time you only see the orange ball. For step 5, we're going to ensure that the ball moves. And to move the ball, we have to update the X and Y position of the ball. Because unlike the paddle, the ball moves in both X and Y direction. Before we can move the ball, we need to get the direction of the ball. And the ball will be moving in the X and Y axis. So we need X and Y for the direction of the ball. To implement this, we'll use the pygame vector2 class. For the X position, I would like to use the choice function from the random module, which we imported earlier here. And for the y axis, the direction, we'll use uniform. Zero 0.7, 0.8. So any number between 0.7 and 0.8 will be randomly generated for the y. To actually move the ball, we need to define a move function, which will take delta time. And we'll update the x value for the rectangle of the ball each time the ball moves. So to do this, we would multiply the x value of the ball's direction by the speed of the ball by the delta time. And we'll do the same thing for the y value of the rectangle. So that will be self dot direction dot y multiplied by self speed multiplied by delta time. We also have to define an update, which we'll call to move the ball. So each time the update function is called, the move function will also be called. Let's try this out. And we don't see anything because the ball moves so fast. If I go to settings, maybe for the ball speed, I reduce it. And we'll try it again. And you can see the ball is moving slowly. But we don't have collisions yet. Step number 6, ball collision. So we're going to implement the ball collision to ensure that the ball bounces around the boundary. And then we also want to check for when the ball collides with the paddle. First of all, we're going to check if the ball collides with the wall. We'll call this method every time in the update function of our ball. So to define the function, first of all, we'll check when the top position of the rectangle for the ball goes beyond 0, in which case we'll set the top position of the rectangle of the ball to 0. And then for the direction of y, we'll multiply that by -1 so that the ball goes in the opposite direction in the y-axis. We need to do the same for the left position of the ball. This time for the direction, we look at the x value and multiply that by -1. And we'll check for when the ball goes beyond the window's width. We'll set this window's width, and I just realized I made an error here. It should be rect.right. The direction of y, direction of x should be set to the opposite direction. And if the ball falls below the window's height, for now, we'll allow the ball to bounce. So self-direct bottom equals screen height. So let me clear the terminal. On the game, and you see that the ball bounces. Let me just increase the speed. All right, so you see the ball bounces through all the different sides, but there's no collision with our paddle, which is what we'll do next. So I'll minimize this. So remember, the ball object also receives the paddle sprite group. And what we're going to do is we're going to have a function that checks to see if there's a collision between the paddle sprites group and the ball. Let me put the function here. We'll call it collision. To take the direction of the ball. It will take the direction. First thing we need to do is to look through the sprites in the paddle sprite group. And if the rectangle of the sprite collides with the rectangle of the ball, then we have a collision and then we want to do something. Here we can check the direction of the collision. So if it's horizontal, else it will be vertical. For the horizontal collision, we need to check what happens when the right side of the ball collides with the left side of the paddle. And to do this, we'll have a simple if statement. But since both the ball and the paddle are both moving, we need to also take into consideration what happens when the old right position of the ball is less than the old left position of the paddle. When we get this collision, the right side of the ball should be set to the left side of the paddle. And then we want the ball to move in the opposite direction for its x value. Before we can test the collision, don't forget that we need to also keep updating the old position of the ball with a copy of its current position. Each time we update the x position of the ball, we like to check if it collided horizontally. And each time we update the y position of the ball, we like to check if the ball collided vertically. So you can see the ball is colliding with the left side of the paddle, but not with the right side of the paddle. So we'll repeat the same thing. And this time we want to check the collision for the right side of the paddle. So we'll check if the left side of the ball is less than or equal to the paddle's right side. We need to check that the old position of the ball on the left side is greater than equal to the old position of the paddle's right side. When this condition is met, the left side of the ball should equal the right side of the paddle, and the direction on the x-axis should be set to the opposite direction. Let's try this again. As you can see, both the left and right side of the paddle collides with the ball. But the ball stream moves through the paddle vertically. And since both the ball and paddle are moving targets, we'll check the old position of the ball's bottom when it is less than or equal to the old position of the paddle's top. When this condition is met, we want to set the bottom of the ball to be equal to the top of the paddle, and then the y value of the direction of the ball should be set to the opposite direction. But you may also add for the bottom of the paddle Let's run the game again. Before we move on to the next step, we would need to add this line. So when the ball collides with the bottom of the window, we need to set the out of bounds flag to true. We'll use this out of bounds flag to create our game over function later. For step 7, we're going to implement the game over function. The game over function will display the game over text and then pause for some few seconds before we close the game window. So back in our main file, we will create the game over function. We'll need to create a font. To create a font in Pygame, we use the sysfont function, which takes name and size and some other parameters. We're going to create the game over surface, which will be used to render our message with the font we've specified. We need to also include the color as well as background color for the surface. We'll create a game over rectangle. Which will be gotten from the game over surface. And we need to set the position for this rectangle. We use mid-top. And for the mid-top, we use half of the window's width for the X position. The window's height, 1/4. And we'll use the bleed function of the screen to draw the text. We need to update the pygame display. Using the time module, we'll sleep for some few seconds. And call the endgame function. Under updates, we'll check when the ball is out of bounds. We'll call the game over function. I'll reduce the speed of the ball. Let's test that again. There's our game over text. For step 8, we're going to draw the bricks on the screen. Remember, our window is broken down into grid pixels, and each grid pixel starts at an X position and also a Y position. And we draw a brick using 2 grid pixels. Each grid pixel has a width of 40 and a height of 40, but for the brick to be made up of 2 grid pixels, therefore, each brick will have a height of 40 and a width of 80. So this yellow brick on the screen starts at a position of X equals to 40 and Y equals to 40. But to draw the brick, we need to know the center position of the brick. To get the center, you can get the starting X of the brick, which is 40, multiplied by 2, which is 80. And that gives you the X for the brick. And to find the center Y, you can take the starting Y, which is 40, plus the ending Y, which is 80, and divide it by 2, which will give you 60. Assuming that we don't know the ending Y of the brick, you can still get the center Y by getting the starting Y and adding half of the grid pixel to it. So if your starting Y is 40 and you add half of the grid pixel, which is 20, you will get 60 as your center Y. We'll be using this second formula in our program, and that will give us a brick like this. After we've drawn the brick, at some point, we also need to check the collision between the brick and the ball so that we can remove the brick from the screen. Back in our entities file, we'll create a new class for brick. So the class name will be called brick, and it will inherit the pygame sprite. Define our init function and make sure to pass group to the parent. So our brick is going to have some properties. One of them is going to be the width of the brick, which is the grid pixel multiplied by 2. And then the height of the brick, which will just be the same height as the grid pixel. The brick also needs to have a color. Let's use dark gray for our bricks. And the brick also needs to have a position. So to draw our brick, we're going to create an image surface area. With the width of the brick and the height of the brick. This time we want to fill the surface with a color. We use light gray. And we like to draw a rectangle inside this image surface. The color of the brick, which is dark gray. Then for the actual rectangle, we use pygame.frect. And here we need to start the passing position for the brick. So because I want the brick to look like it has a border, I'll offset the starting X and Y this time by 2 pixels each. And for the width and height of our rectangle inside this image surface, we're going to remove 4 pixels each. So for the width, we'll set 0 and 2 for border radius. We also need to declare a rectangle which we'll use later for the collision between the ball and the brick. And the center of this rectangle will be set to the position of this brick. So you notice this error here. For our brick, anytime we instantiate it, we also need to pass the ball sprite so that we can use this to check our collision between any brick and the ball. Also, the position that we like the brick to appear. So we'll save this and go to our main file. We'll create our brick in the initialization function of the game app. Self.brick plus brick. We'll pass our group itself dot all sprites, and then we'll need to pass the ball sprites to check collision. And let's say that we want the brick center to be at position 80 for X and 60 for Y. Let's clear our terminal and run the game again. This needs to be pygame.draw. Let's run our game again. And this time you can see our brick. To test the collision between the brick and the ball, you have to get the ball sprite group. And we also have a new property called alive for each brick, which will be set to true. Anytime alive is set to true, we will render the brick on the screen. When alive is false, we'll remove the brick from the screen. To detect collision, we'll have a check collision function. And as usual, we'll check the sprite in the ball sprite group. And if the sprite correlates with the rectangle of the brick, then want to set the alive property of the brick to false. And we want to update the direction of the ball by multiplying it by -1. We also need to declare an update function where we'll check the collision between the ball and the brick. Let's run the game to test this. All right, so we see a collision between the ball and the brick, but the brick is still on the screen. To fix that, we need to change the way our brick is being rendered. And one easy way to do that is to create another class for the brick sprite that will have its own draw method. So we'll create a class and call it brick sprites. Which will also inherit the sprite group. It will have its init function. We'll also call the init function of the parent. Let's get the screen of our game using pygame.display.getSurface. Here we have draw function to override the draw of the parent. Basically, we're looping through all the sprites that belong to the brick sprites group. And for each sprite, if its alive property is set to true, only then do we want to draw the sprite onto the screen. Let's save this. Before I forget, we need to remove this delta time here. In the main file, we'll have a new sprite group for the bricks. So let's call it brick sprites. It will belong each, and this time our brick will belong to the brick sprites. When you run the game again, you will notice that the brick is no longer on the screen. To fix this, we need to also call the self.bricks sprites.update. This time, we're not passing the delta time because brick is static. We don't expect it to move. And under the draw section, you also need to call self.brick sprites.draw. We don't need to pass the screen this time into this draw function because if you remember, in our bricks class, we're getting the surface of the screen. When we run the app again, you can see the brick. So anytime the ball collides with the brick disappears, which is fine. But our game will not be interesting if we have only one brick on the screen. To draw multiple bricks on the screen, I would like to loop for I in a range starting from 4 to, let's say, 10. And we want to go in the steps of 2. This I will be for the center X of the screen. And then I would like to loop for J in the range of 2 to 5 for the Y. All right. So this will give us center X and this will give us center Y. And within the nested group, we like to create a brick self.brick sprites for the group. We like to pass the ball sprites to check our collision with the ball. And then our center X and center Y. So for the center X, I just want the grid pixel multiplied by Y. And for center Y, I want half of the grid pixel size plus the grid pixel multiplied by J. This will ensure that we have multiple bricks on the screen at different positions. Let's test this out. As you can see, we have more bricks on the screen that can collide with the ball. If you would like, you can store all these bricks in a list using list comprehension. Let's run the game again. And as you can see, we still have our bricks. But we're not done quite yet. In our update section, we want to loop for all the bricks in our bricks group. And anytime the alive property of a brick is set to false, we'd like to remove that brick from the list of bricks. And also from the bricks sprites group. As well as delete that brick. Let me increase the ball speed slightly. And run our game again. So our bricks are being destroyed when they collide with the ball. Step 9, display score onto the screen. In our main file, we'll create a new function called display score. We'll create a font for the score. You can use any available font to your liking. And also we need to set the font size. We also need to create the text for the font using the font render function. And we'll pass the f string, score, and then the actual score of the player. And the aliasing set to true, and the color of our text, we would like to use light gray. Then we'll draw the score onto the screen using the blitz method. And we also need to pass the position of this text. So 10 for X and 10 for Y. Inside our run function, under the draw section, we're going to call self.displayscore, and that is it. So let's test this game and make sure that our score is being shown. There you have it, our score is being shown. We also need to update the score each time the player hits a brick. So each time a brick is being destroyed by the player, we need to update our score by the points we defined in our settings file. So the score will be incremented by 100 points. Let's test the game again. Anytime you have a collision, the score increases by 100. So for step 10, we need to check if the player has won a game, and when the player has won a game, we display a message. So in our main file, we're going to declare a check win function. For the check win function, we're going to check the length of the brick sprite group, and when that gets to 0, we display a message to the user. So we'll create a font. With font size of 50. We'll create a font surface. With the message "you have won." Set anti-aliasing to true. And give a color for the font and a color for the background. We'll get a rectangle from our surface. And set the mid top of our rectangle to half of the screen for X, a quarter of the screen for Y. We will draw our text onto the screen. And update the display. Let's also delay the game for some few seconds using time.sleep, then end the game. And we'll call this function just before we update our display. Let's try it out. Launch the game again. There you see our message, "you have won the game." And that's it for our game. Feel free to extend the features of the game, such as storing and displaying the highest score, and any other ideas that you may have. You can also find the codes for each of the various steps on the GitHub repository using this link. Thank you and bye for now. Thank you for hanging out till the end. If you enjoyed this, give it a thumbs up, drop a comment and share it with a friend. Hit subscribe so you don't miss future videos, and check out this one on the screen. Catch you next time.